Alright, this lesson is going to go over the following ionic solids. However, we're going to be using something called the ICE table or R.I.C.E table, which is the reaction, the initial concentration, the change in concentration, the equilibrium concentration. So here we're going to be starting with a solid. The first step in the R.I.C.E table, let's write out the R.I.C.E. Again, the reaction itself, the initial concentration, the change of concentration, and the equilibrium concentration. So we have, in this case, in this example, we have PbCrO4, and we're given a value of the entire reaction. I'm going to draw out the equilibrium reaction. So we have the aqueous ions. Put AQ for aqueous. Let's put an S for solid here. CrO4, 2 negative, and aqueous ions again. Since this is solid, it's not going to be part of our equilibrium KSP constant. I'll put lines here to indicate what I need to fill out. The initial isn't going to change, so we're going to have 0 written there. And we want to then change this into a variable. I like to use the x variable, so we're going to use variable x. Again, it doesn't matter what variable you use, I just tend to use x often. So your equilibrium concentration will merely just be this variable. And we'll give an example when something wouldn't be just plus 1x. And because you're having nothing to coefficients, we've balanced it. I didn't double check it, but I'm looking at it now and it's balanced. So my KSP is equal to 2.0 times 10 to the negative 4th, and that's equal to Pb2 plus concentration and CrO4 2 negative concentration. My variables for those, I can plug them in right here. I'm going to do the work here since I'm kind of running out of space. I'll put my variable here, x and x. So 2.0 times 10 to the negative 4th equals x times x, which is the same thing as x squared. So now my mathematics, in order to get x variable by itself, I'm going to take the square root. So I'll take the square root, 2.0 times 10 to the negative 4th, and I get my answer. Right, I know I'm running out of space, so I'm going to put my answer up here. So my variable for x will equal, x is equal to 1.4 times 10 to the negative 2nd molarity, which now I can properly write that as both of these aqueous ions are equal to 1.4 times 10 to the negative 2nd, as well as CrO4, 2 negative, equals 1.4 times 10 to the negative 2nd molarity. So I'm going to box that in since it had to be rerouted up there. Alright, that's an example when we have KSP and we have the variables just x, and the coefficients are all 1 for the equilibrium, or the equilibrium reaction rather. Now let's move down to this problem right here. Alright, so we have iron hydroxide. And the first thing we need to do for iron hydroxide is write out its equation. So instead of iron hydroxide, let's just do silver sulfide, since it's the next one. I'm going to set up my R.I.C.E table, condense it a little bit more just so I have more room. And I'm going to write out the equation itself. So I have my solid, Ag2S, which is a solid. At equilibrium, the ions dissociate to Ag in aqueous form. And then we have sulfur, which is -2, and we put aqueous as well. We then need to balance the equation, so we have 2 silver here, so let's put a 2 there. The rest of the ICE table is not going to have anything written because this is a solid. our initials are going to be 0. The change in concentration is now going to be a variable, and I'm going to use x for silver, so it's 2x for my variable. And here I have, it's a positive 2x because the change is positive. And then we have 1x here because I'm just changing that chemical into a variable. So let's rewrite there that equilibrium to just have the variables without the positives. Now I'm going to write out my K equilibrium KSP. There we go. Is equal to 1 times 10 to the negative 49th. And first let's write out the constant. So Ag plus 1, and the coefficient was 2, so I'm going to square that. And then we have sulfur negative 2, and that's what the constant looks like. It's over 1 because we have a solid, and we learned that from the previous lesson. So now let's put my variables in so we can solve it mathematically. We have 2x represents Ag, so I'm going to have an equation that looks like this, times x. All right, so 2x squared is actually equal to 4x squared. That's what the answer would be. 4x squared times x is equal to 4x cubed. A little bit of math there. So 2x squared, you get 4x squared, times x is 4x cubed. So 4x cubed is equal to 1 times 10 to the negative 49. So let's draw that math up here. 4x cubed equals 1 times 10 to the negative 49th. We'll divide that by 4, and we'll get x cubed is equal to 2.5 times 10 to the negative 50. And then we take the cube root, and we get 2.92 times 10 to the negative 17. So in your calculators, often you might have the ability to cube it. Some of you may know better than me. If you don't, you can use the caret key, this little key right here. So you would take the answer of 2.5 times 10 to the negative 50, and then you would caret key, and then because you want to take the cube root, you would put 1 over 3, 1/3. That's what the caret key, 1/3, you would get this answer for x. But that's not the actual answer what we're asking for. We're asking for what the values are. So then you need to plug in the value of x for silver. So it's 2 times x. So you plug in that value to get silver. And then you do the same thing. You just plug in the sulfur. Well, sulfur is that, so you just have that value right there. So your ion for that would be that, and your ion value for silver would be that right there. So by quickly typing that into the calculator, 2.92 times the negative 17 times 2, I got 5.84 times 10 to the negative 17. And then this answer is 2.92 times 10 to the negative 17. A lot of arrows, but here's the answer. Box that in. All right, so now it's time for you guys to practice.